this one?
Yo, 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 what is Gucci, everybody? What is Gucci, Gooch, Gooch? It is your boy J Siegs with Pascal's triangle number dos. So, for those of you who don't know what Pascal's triangle is, um, it's actually, this diagram is very good at describing it. I don't think I need to draw anything out. This is really nice. It basically adds ones to the sides, and then the inside things are going to be the sum of the two above things. Okay, so what you asking us to do? Given a non-negative k-index in the row, note that Pascal's rows start from 0. You just want me to give you this, the third row, which is here, because it's zero-based indexing. Okay, well that doesn't seem that bad, to be honest. I like how this is locked.
Okay, I got E.
Wow, I think I see which ones this is. Is that supposed to be like blurred out? Because I could clearly see that. Okay. Whatever. Okay. So let's
Oh my god.
So
You literally just bolted.
I can't think of a way to do this besides just computing bottom up. Like I have to do this 3 times. Like, yeah. Okay. So basically what I want is I'm gonna have a for loop. Wow. I is less than well, actually we're gonna go less than or equal to row index I plus plus, and then so let's do vector int current row, and then vector int next row. Okay, so what we can do is here we can do let's actually so current row yeah, I think you could do that. So then
where's the settings? I can't even escape. Oh.
Actually, I kind of like working off of the previous row. And let's set that equal to 1. Okay, and then this current row could be there. Okay, so now we're actually at 1. You need to have a base. So what you're gonna do is not do it like this. You are going to do it right here. And first off, you do know the size, so it's gonna get prev row. It's just plus 1. Plus 1, comma. What do I want to put in there? Let's just put in there ones, right? Because the outer ones. Now the outer ones are being put in. So, then I'm gonna go like to the inside ones. J equals 1, and
I'm on the next one.
I want to go J is less than current row dot size minus 1. And I wanted to do that because I don't want to mess with these outer ones, you know? I want to start one after that, and I want to end right before the last one, because I don't want to touch those ones. I just want to touch the inside ones. So, okay, so we got current row, and now we're only working on the middle ones. If it's the second row, or sorry, if it's the first row, this is the 0th row. If it is the first row, then 1 is not, and then j is going to be 1, and current size is going to be 2 minus 1 is 1, so then 1 less than 1 is not going to fly. Okay, so then what I want to do is do prev row gets
I didn't graph it.
current row.
Oh.
And yeah, and what do I want to return at the end here? I think I want to still return the current row. But I can't, can I? So if I'm going equals to, it's gonna compute the third row, for example, when I is 3, and
I'm so slow at pressing the buttons.
then I want to return
I'm like
it right there. Okay, I'm just gonna, okay, I'll do this. So return vector, and this is gonna be like a dummy thing, -1 or something, or nothing. Return vector, and I don't know if that works. I'm gonna do this.
You actually don't even have to find the second derivative, because if you find
if I equals row
I put in the first
index, return the current row right there, and else, well, there's no else. It's going to be cleared anyway. It's going to be cleared there. Okay, so how do I do this? So I have this previous row, and so it's going to be kind of simple, I think. So current row j gets previous row j minus 1 plus previous row j. And for example, that's going to be, if we're like in the second row, it's going to be, actually let's go to the 4th row, where this is the, yeah, 4th row. So here is going to get, if j is 1, so it's going to get this current row j is going to get the previous row 0 plus the 1. Then this is going to get the current row at 2 is going to get the previous row index at 1 plus the previous row at 2. And then same goes for here, and then we are done. Okay? So I think this works. I don't think it should ever get here, because this is running.
How are you sure, like,
this is running
if you look at a graph, or you can never
that many times. I feel like there might be a more elegant way to do this, like you only run it. If you have to run it this many times, and then I just want access to it. Yeah, I mean, I think this is fine. Let's just, I don't know if I could return that. That's the only thing I'm thinking of. Row index, that is not allowed.
Right, sometimes like it's hard to tell exactly where.
Did I spell something wrong? Expected comma or semicolon.
Okay,
oh, this.
Where's the point of function?
Okay, and even for the 0th row, it's gonna work because it starts at 1 and then this is 0. And then it's just gonna, oh, we should just return previous, and that's what we should, for previous row. Okay, and that's for this case here. Okay, let's submit it. Or I should have, whatever.
That is where the
nice.
concavity is.
First time, 100%. Okay, let's take a look at some other solutions, and then we'll be done.
My calculator only gives me one value.
Oh yeah, did I do this in O of K space? What is K? I think I used even less space than that. Yeah, I just used the space of one row. Recursion, interesting. So let's see, if row index equals 0, return that. Ooh, that's what I should. Nah, minus. I like that.
Well, you could. I mean, don't think
Get row
let's see.
index.
Let's see if it
that.
does it on your
Oh, this is like a top-down solution. Interesting. So I did mine bottom up. This is top down. Because you have the index like 3, and then you're trying to find 2, 1, blah, blah, blah. Then you get to here eventually. And you return 1. That's great. Then it pops back to here, and v just got 1. And then n gets v dot size, which is just 1, and then vi gets this. If I is less than n over 2, vi gets vi and n minus 1. N minus I. Also just gets vn minus I. This is really weird. So you're saying that... Could I open this in a new tab? So you're saying that you could just add... What are you saying? You could add I, which is like 1, and then 1 from the end, and put it in I.
It is too hard.
Huh. Then you just push back 1 off the end. But why would v of n minus I be solved if... I don't know. I don't like that at all. No extra space. Okay. You resize row to be that. Sure. Then R0 gets 1, and so does the index. Ooh, I kind of like the syntax. And then you could have also done this all in one step by just doing vector get size row index plus 1 and fill them all with 1s. But that's okay. So then for auto I equals 1. Okay. I love how we used auto. That's so stupid. Int is literally less characters than auto. The whole point of auto is to avoid writing like some huge type, but int is literally less than auto. Okay, so you're only going halfway through, and then you're saying those are equivalent. I like the syntax. He's saying the first and the last are both gonna get r I minus 1 times what? This is what he's doing. He's doing that formula.
Okay, so basically it says, you're not
which is gonna be
inflection point just by looking So, but you know that it's between the extremas. Extremas? Uh,
Obviously, I don't have them.
yeah, because, well, it's between where it changes from concave down to concave up. So you can find the roots of the second derivative, or you can find the roots of the function,
Interesting. Okay, whatever. I will see you guys next time. I don't really understand this, but that's okay. See ya.